This is nice here, engineer. Of course, the part about the indication is next to a very beautiful circle here, which we will talk about now. All right, engineer, first you need to see what your cell looks like. What is it that you want to say, Engineer Rashad? I'm not going to explain this indication. I want to take this circle. Do you see this circle? All right, take this circle. I took it here alone, yes, but before I go into it. But engineer, right now in your cell, you have two things, and I've summarized them for you in the paper with 2 lines. Here, you have something called a lever, and below here, you have something called the knob. The knob, and this is called the lever. All right, this lever, engineer, is specific to the electrical cutting, and the knob is related to the air switch. I'll play a video for you, and I'm also recording it so you can see how the process works. Great, you told me it's very nice. So what do you mean by this lever, Engineer Rashid? This lever, quite simply, shows you a breaker drawn here and a shape of a breaker drawn here, and it writes breaker for you, moving right and left. All right, rec out, rec in, and it marks here as prohibited. Okay, very nice. So where is the rec in and where is rec out? This is the rec in, which is the bus bar, and here is what? Here is the feeder, and of course it is rec out of service. And here, the same thing, it is rack what? Rack out. Okay, here it tells you if this lever, which is the black handle, if you place it at the off position, which is called breaker what? Meaning it is free to be either. Free, meaning it is free to be either racked in or out. Racked in the direction of the arrow like this, or racked out in the outward direction, okay? And if it is here, Engineer Bashad, if it is in the H position, H means held or hold, meaning something is held. The breaker is held in the test position, meaning the breaker is held in the test position and cannot be racked in. So in the free position, if this lever is in the free position, you are allowed to move the breaker racked in or racked out. Okay, and if it is in the hold position, then first of all, the breaker must be racked out. It must be racked out, okay? And at that time, it will be prohibited to rack it in. If it is racked in, you cannot put it in the H position. So the H position means what? It means the breaker is racked out, okay. So with the H position, you will never be able to move this lever, the black handle, to the H position when the breaker is racked out. And if you set it to the H position, you won't be able to rotate the breaker or rack the breaker in, rack in. Okay. Now, with the lever, for example, in a scheme like ABB, there might be something like a plug, and you have something called RL1, RL2, and RL3. It's like a plug that when you try to rack in the breaker, this plug stops you, so you can't rack in or R. But here, it's a mechanical system in the ABB at Alphanar, so it doesn't matter. They all have the same idea. There's a position where you can rack the breaker in and out, and another position where the breaker must be racked out. If you set it to this position, it won't be allowed for you to rack in. All right, very good. And here I have this part, which is this knob, and it's related to the earth switch. So what is this, Engineer Rashad? This knob related to the earth switch has 3 positions, A, B, C. Nice, I told him. He said, okay, look here with me. What is this? It's drawn for you that the earth switch is open. And here there is an F. And here is drawn for you that you have this place, which is this spot. It's drawn for you to insert a handle and stand to rotate it clockwise or counterclockwise. And as for our final position, which is the C position, it's made for you here that the switch disc is closed and there's a lock position. Okay, great. So what does this mean? As long as you are in the A position, it means you can't switch to the A position unless the switch disc is open. All right, very good. So let's say something. Let's say that now this knob is in the B position. All right, so now you are allowed to insert the handle here. And to close the breaker, what did it say? It said to turn it with the switch disc, turn it clockwise. And to open it, you turn it counterclockwise. Here you have the ground. Is it open like this position or closed when it's drawn horizontally like this? All right. When you set it to the B position, you insert the handle to close or open. If you open the ground, then you bring this black knob to the A position. If you set it to the A position, you can put a lock on it so no one can switch it back to the B position and close the ground. And if you close the ground, this knob won't go to the A position. It can go to the C position. In this case, you put a lock so no one can open the ground because you are now Going to work on maintenance. All right. As you can see, it tells you to make the earth switch on. You press this knob. Then rotate to position B. So you press it inward to bring it to position B. It tells you why to press, because as long as it's out like this, there's a lock in place. So to press, you need to remove this lock. Now, behind me in the video, you press it and bring it to which position? Position B. As soon as you bring it to position B, what does that mean? You've turned it and brought it to position B. You insert the handle here. So you operate it, as you see, in which direction? The name indicates which direction the ON. Okay, with me. Now, what does it tell you here? Yes, here, it's talking to you about what you're saying. Come on, Engineer Rashid, I'll tell you very simply. Let's take a look together. Let's zoom in on the picture like this. When I came and explained to you here, I told you that I have this and that, right? Okay, great. So he sees that these two are present in the same cell, right or wrong? So he told you, instead of using something, for example, I can use. So I will create a mechanical interlock here between the breaker and the air switch. He draws a dotted line like this, and this line has a triangle drawn on it in a dark color. This means there is a mechanical interlock between these two pieces of equipment. Between which equipment? Between these two pieces of equipment. Great, very good. Okay, let's go back again. Here, I'm coming back to you again. So here, engineer, where's the idea? Come on. Now that you understand what this lever means and what this knob means, let's merge the two or integrate them. Now, for the breaker to perform a rack in or rack out operation, for a rack in or rack out operation, the ground must be open. But this knob must be in a specific position. All right, great. So I won't be able to take this lever and put it in position. Sorry, I won't be able to take this lever. I won't be able to operate the breaker in rack in or rack out mode as long as this lever is not in the A position. The A position means that the air switch is open and there is no intention to close it. No intention to close it. Well, if you set it to position B, it means you have access, meaning you can go to the ground to close it easily and correctly. You'll find that as soon as you move this lever to position B, something mechanical will come out inside to prevent you from being able to rack in your circuit breaker. All right, that's good. And if you're on position C, the same thing applies. You won't be able to rack in our breaker. Okay, fine. Suppose the breaker is racked in. If the breaker is already racked in, you won't be able to move this lever to position B or C at all. So how does the mechanical interlock work? If the breaker is racked in, you will never be able to move this lever from A to B or C. It will remain in position A. All right. If the breaker is racked out, in the breaker, regardless of whether it's F or H, if the breaker is racked out, you are allowed to move this knob from A to B. Then, if you close the ground, you can switch it to C. If you move it from A to B, it means you intend to ground it, regardless of whether you actually close it or not. As long as you set it to position B, it means this spot opens up for you, and you can insert the handle and close the ground. As long as you have the intention, without actually closing the ground itself, you won't be allowed to do what? To rack in the circuit breaker, because it will be mechanically held. All right, guys, so this is the mechanical interlock between these two. Okay, that's for the ground I have. Now, suppose there's a ground for the bus bar, meaning suppose the bus bar's ground is closed. If I close the breaker, then I'm connecting power from my feeder to the bus bar that is grounded. So what does that mean? It means that what will happen is a short circuit, right? Or am I wrong? Okay, so here I have created a mechanical interlock between the movement of the breaker rack, whether it's rack in or rack out, with my air switch, right? But for the air switch that is located in another cell, which might be 10 cells away from me, where the ground is like at the bus riser, for example, what should I do there? Well, I can't create a mechanical interlock, so how do I create an electrical interlock? It's very simple. They told you, when you start to pull the breaker out, at that time, a break or a nice pause so that the ground stops, 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 the ground stops. And it's position all the brackets you have on the same section of yours. You put them all in the position. All right? Here, in this part that is here. In this part here, there is a knob like this, all right. Now, if you close the ground of the bar and try to lift this from the latch, it won't come back with you. You must open the ground of the bar. Oh, yes. So here you have created a position like this, between this and that, right? But why did you create this from the beginning? Why did you make a position for it at all, right? As long as I can get it from and start moving freely, yes, this is for the other things outside my cell. What is outside my cell? Like, for example, a bus bar. All right. So Bash and Rashad, could you please explain the bus bar more? Yes, of course. Come here. Here it is again. The idea of it. Now you have it like this. Now you have here your entire bus bar. All right. And here is your bus riser. Then here you have your bus section. All good. You have a set of breakers like this. And here, of course, you have the bus bar transfer switch. All right. Of course, these are all withdrawable circuit breakers. Is that correct? Okay, I want to close this ground. If I close this ground and then close one of these, one of them might supply me with power. Right or wrong? One of them might connect to a capacitor. So it would discharge the capacitor. And that's also wrong. Right or wrong? Also right? So what did they tell you? If you're going to close the ground bus bar, why are you closing it? To ground the bar? Why ground the bar? It is under maintenance. While it is under maintenance, disconnect all loads. And that's what we know. This is one of the defects we talked about at the beginning with the single bus, single breaker. Am I right or wrong? That's why we even created a topic and divided my loads so that instead of all being out at once, they are now divided. Right? Right? So for you to close the bus bar, all these breakers must be in a rack out position. Okay, engineer Rashad, I can close it after I have taken it out to the rack out position, right? That's why I always like to say the word rack out. Dion, I always say all breakers should be rack out. But twice when I gave this course, I found some people coming to me saying, engineer, how can I make it rack out when it's not open? I had to explain that open is like rack out. But if you want to be correct, there's no such thing as open. It must be rack out. You can't take the breakers to rack out unless they are open. That's it. But after you have taken them to rack out, you can close them as you wish, whether you are performing maintenance on them or removing them completely, right? Am I wrong? The important thing for me is that all breakers should be in rack out. I wanted to make sure you understand how important it is. All the breakers must be in rack out, right? Well, after you rack them out, can I put them back in rack in again? No, they should remain in rack out. And your lever should be in the H position, not the F position. The lever must be in the H position. So what did I gain from this? I'll tell you what you gained. Didn't you take them all to rack out and set them to H? You said yes, and they are on the ground. As soon as they touch the ground, there's a mechanism and a coil. All right, very good. So now to switch back from HLF, you won't be able to. Why? Because this mechanism or lever, which they call a mechanism, but let's say lever or interlock or mechanical interlock or like a pin, is locking the blade. So you can't move this lever, the black one, from HLF. Okay, and to move it, you need to open the air switch. When you open it, you'll find that this coil has DC and takes the state of the air switch. So once the air switch is open, it will operate and pull this mechanism or lever back, allowing you to switch it from the H position to the F position. This way, you can perform a rack-in operation for the breakers because you are assured that the bus bar air switch is open. Great, guys. Very clear, right? Great. Very outstandingly excellent indeed. Okay, come with me now. Let's go up here. Let's first watch the video we were talking about earlier. Just a moment. Where is our lecture? Here we are. Let's watch together the video of the switch gear that we were operating, right? Okay, let's see the topic of grounding with this breaker. This is another factory, but I want to show you, for example, how the mechanical operation is done there. Look with me now, you want to stop the grounding, right? They have a different system. They don't have H and F and they don't have the knob, but what do they have? They have F. He will open this door. Now focus with me at this moment. All right, he told you, these are the mechanical interlocks. This is the mechanical interlock he has here. It's called shutter door. We call it that, shutter door. All right, let me write it down in case someone didn't hear me well. It's called shutter door, okay, which is this door. I wrote it down for you so that when you watch the video or review it, you can see. As soon as you lower this shutter down, it means that now you have the place where you will insert the handle of the isolator to close it, right or wrong. Look with me now at what will happen inside. Here, a tongue comes out, see? So what will happen with this tongue? If you try to insert the breakers, look here, see?
You will hit here. Where will you hit here in this place? So you don't know how to make a rack. You might say, okay, suppose any rack, if it's a rack, you see this metallic place, how was the tongue going to hit? So the tongue didn't know how to open properly. I told you. So you didn't know how to open these clever ones. As long as the breaker rack didn't know how to open these clever ones, which are in the switchgear state, the spring wouldn't know how to bring it to the B position. It wouldn't know how to bring the knob to the B position, right? And if it's rack out, it's done, it went down. Or it might be placed in B, or it might not be placed in B. Is it an earth fault? No, it's not an earth fault. No, it's not an earth fault. And who is doing what? Does he intend to close the A, close the NR, right? Okay, now let me play it for you with sound B here. This was a part I previously gave to the guys, so I'll play the video for you to listen along with me. No, it's fine. The picture is clear, okay? In the name of God, the most gracious, the most merciful. Of course, here we will see if the sound is clear for you. Is my voice in the video clear or not? I hope the guys can write to me in the chat so I know. Okay, it's clear. Yes, all right. Everyone wrote that it's clear. Very good. Let's go again. In the name of God, our panel is 13.8 kV. The manufacturer, of course, is the company Fanot, as Mr. Ahmed Sharif explained to you. If you look at the panel from a front view, it is divided into three parts: the upper part and the middle part, the lower part. And of course, from the side, it is divided into two sections, the front part and the rear part. Now, regarding the front view of the panel, we agreed that the upper part is what is referred to, which contains the middle part where the circuit breaker is located, and the lower part where the voltage transformer and the earth switch are located. And of course, the panel we have here from the side, if you look at it as a side view, its end will be the front, which will have the low voltage compartment and the breaker, as we agreed, and the last section, which is the VT and the air switch. From the back, you will have the upper part containing the bus bar, your three-phase bus bars, and in the middle section, as you can see here, exactly as you can see here, you will find the three current transformers. Of the three-phase current transformer, and the last part, which has the cable termination end, which is so that my cables will finally connect here, as you can see, the bus bar, for example, the red phase, the yellow phase, and my blue phase, very nice. A blue phase, very nice. All right, let's go back here to the panel and also handle the part which is the first part, the low voltage compartment. Of course, I have here the low voltage door, which will have, for example, the ammeter, the indication lamp, and here you will have a box containing a set of auxiliary relays in addition to the test switches used for testing the PCU or PCPU, the bay of control and protection unit, which is the relay NADS that engineer Ahmed explained to you, which is the control unit of the cell and also shock protection. As you can see, it is drawn here so that you can control it from here. Nice. You have, of course, the one that was there, as you can see, and you have the control mode, which had the off, as you can see, the off, and you have the local, and you have the emergency, and you have the remote. In addition, of course, to the capacitive voltage indicator that engineer Ahmed explained perfectly. If we open the panel here, inside the panel, if we look inside our housing, we will find this is your front view. It will be a set of terminal blocks. These terminal blocks and these terminal blocks, these two are what they are for, and here I have the terminal block. I'll move the camera for you like this. This is a slide link terminal block, and it is used in current transformer circuits. Here we have a side view or a right side view. a set of miniature circuit breakers used in DC circuits and AC circuits, in addition to GT circuits. On the other side, or the left side view, there is also a set of MCBs, a set of terminal blocks. And here we have the heater that is located inside the panel to operate in case of humidity and temperature conditions inside the panel. Of course, here we have the lamp that is specific to our panel, as I mentioned to you earlier. The first circuit we have as an AC primary is that you have this limit switch above. When the panel door closes, this lamp will turn off. And when the panel door opens, it will start. This lamp will turn on. Of course, it's not connected to the cell, which is why you see the lamp is not lit. From the back, as you can see, it's just the concept or the whole idea, which consists of its set of cards, whether they are or the analog for expanding on it with the current and voltage transformer. Here you have your switches. This is the discriminancy switch and the selector switch. And here is the capacitive voltage indicator. Here are the three terminals that come on it as red. And also here you have the red, yellow, and blue terminals, which are R, S, and T. It might be labeled as R, Y, P, or A, B, C, or R, S, and T. Now we will move to the next part, which is the circuit breaker part, the middle part that we have here. We will find written on it the type of meter. Here I have a 13.8 kV transformer incoming panel. All right, it will be drawn here for your cell, as you can see. Here is the bus bar. Here is the symbol of, or the symbol of. This is the symbol of, the symbol of. And here we have this, and here we have here this for the whole cell. This explains. And here we have this, and here we have the. Here we have this for the whole cell. This is what Engineer Faiz is explaining. Is there anything? Mr. Bashwans, did you open the mic because you have a question or something? Okay, maybe it was opened by mistake. The nameplate of the cell along with the circuit breaker or circuit breaker here. Who is the manufacturer talking to? Where is the place and which country? The standard, everything in addition to the nameplate of the circuit breaker. Some of the young people with us are present in the packet switch generation, attended the circuit breaker course, and saw the nameplate with them during the explanation. Here you have part A, so you can see the circuit breaker internally. You can see from it whether the breaker is charged or not, whether the breaker is closed or open, so you can determine the status of the breaker. Additionally, you have something like a nameplate here, or what we call an instruction plate, which has the operating instructions for the breaker and the grounding switch instructions written on it in both languages. Of course, you have it here in the language English, and here you have it in Arabic. Perfect. Very nice. And here we have this, which we start to open, as you can see with me, in order to do it. And as you can see, it writes for you and makes the mark. So Engineer Abdul Rahman is telling me the video sound is not clear. Is the video sound clear for you or not? Clear. Okay. Engineer Abdul Rahman, if you could please exit and re-enter. Maybe there's an issue on your end, or increase your volume or something. It makes the mark, or counterclockwise. You start to insert your handle and begin to rack on or rack out the circuit breaker. All right, guys, very nice. Or if we open the housing from the inside like this, we will start to see this is the housing of the circuit breaker. This is the low voltage plug, LVB. And inside here, we have the two shutter doors that Engineer Ahmed was talking about. Here is the shutter door. This is the shutter door for the part related to the cables, or these are the terminals that will eventually be connected to the cable. And I have the second shutter door, which is the part related to the bus bar that comes from the bus bar side. And of course, we know the benefit of the shutter door, as Engineer Ahmed mentioned, for maintenance purposes. Like now, when we take the circuit breaker out for maintenance, it is supposed that any operator working here inside during maintenance should not accidentally have their tools, hand, or anything come close to the area here, which could cause an electrical shock. And this is the complete housing of the circuit breaker, and this is the handle as we have followed. Of course, as Engineer Ahmed mentioned, there are cases where the breaker might be internally connected and the electrical circuit above might have experienced a failure or disconnection. I want to open the circuit breaker in an emergency condition. If we look outside here on the door, we will find something called emergency off. What is the emergency off? It's a switch like the one you see here. I'll show you how it works. It's a push button. So if you look at the switch from here, the first thing is that the switch turns and then this lever starts to come out. Of course, if this door is closed, this lever would be exactly aligned with the open position of the circuit breaker. Then Engineer Mohammed presses the push button. And as he presses the push button, the lever starts to move forward, appearing as if it is manually opening the circuit breaker or mechanically opening my circuit breaker. Nice? All right. Then the last part, all right, the downside here, or the last part, we have the bottom part, which contains the BT and the earthing switch. Of course, you were just talking with Engineer Ahmed, and now we have this lever. Here is the free position, and here is the hold position. Here we have the knob for the discrete position, which accommodates the A, B, and C. Here is the A, as you can see, it's marked on it, and you can close it. The B means you have inserted the handle, and the C means you can close it, meaning you can close it. As you can see here, as long as this place is in position A or position C, it means you can put a lock here and close it. But if you move it here to position B, you'll find that this place, when you achieve position B, won't be necessary. Once you close this area, this lever will be inside, and you won't need to put any effort. Got it, guys? Great. And here we have the place where we insert the handle for the earth switch. And here we have the position indicator for the earth switch, as you can see. I told you about the earth switch. As you can see now, it is open. Nice. Okay. Regarding the mechanics, Engineer Ahmed was telling you about the interaction between the earth switch and the electrical cutoff. As you can see here, we have this lever and the similar lever inside on the other side. Very nice. As soon as I want to close the earth switch, I need to move my hand or my knob from position A to position B. Let's look at it and notice when I bring it to position B. This lever, as you can see, is now in position B. Therefore, if the circuit breaker is already racked in, it would be impossible to make such a movement because this lever would collide with the electrical cutoff. That's why it requires the breaker to be racked out. The other thing is that you cannot move this knob to position H as long as the breaker is racked in. You must rack it out. After you rack the breaker out, even if you haven't closed the earth switch. As soon as you move the knob from position H to F, as you can see, the same lever moves. This means that this lever or lock can be activated in two cases: if you were going to close the earth switch, or if you move the circuit breaker from the free position to the hold position. This is the mechanical interlock that Engineer Ahmed was explaining to you. I want to show you now the earth switch operation as well to see how it closes. So now I will move it from position A to position B. Engineer Mohammed Azouzi will assist me now. Let's take a look at the earth switch. One moment, Engineer Mohammed. I need the flashlight, or yes, the flash. As you can see here, this is the earth, here is its lever. One moment, Engineer Mohammed. Here is its lever, here is one end, and here is the other end. I want you to look with me at the lever now as it closes. Yes, it closed, Engineer Mohammed. This is how the earth closes. Open it again, Engineer Mohammed. This is how the earth opens. I would like to show you here on the side, right underneath. One moment. Here, there is a spring underneath. What's up, Engineer Mohammed? This is the spring that Engineer Ahmed was talking to you about. Open it again. This is the spring to ensure it closes quickly and allows for rapid discharge of charges. Is that clear, guys?